Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kindly refers to the example. Determine whether the function given fx is a continuous at x is equals to 4. So in here notice that we have the modulus for the x minus 4. So kindly define the situation. Modulus x minus 4. So if we define, we have x minus 4, bracket, we have negative x minus 4. Then we have the domain x greater equals to 4, x less than 4. So kindly illustrate the situation in the real number line. So for the left hand side, we have x less than 4. So here we have negative x minus 4. For the right hand side, we have x minus 4. So if it's equals to 4, we have x minus 4 as well. Next, kindly focus on the question. Question mentioned about the continuity. So step number 1, f4. If it refers to the number line, we are moving towards the right hand side where we have to substitute the 4 into the x minus 4. Then we will have the situation. So x minus 4 minus the 2 over the x. So if we substitute, we will have negative 2 over the 4 and we can have negative 1 over 2. So if for the f4. Second step is to find the limit when x approaching 4 from the left, and we have another one, limit when x approaching 4 from the right. So kindly substitute the situation. So based on the situation given, 4 from the left. So we will have negative bracket x minus 4 minus the 2 over the x. So rewrite the situation, limit when x approaching 4 from the left. So 4 from the left, we will have negative x plus with the 4 minus with the 2 over the x. Limit when x approaching 4 from the left. So notice that we have negative x plus with the 2 over the x. So kindly substitute the situation. So if we substitute the negative 4 plus with the 2, so we will have negative 2 over the 4. So from here, we have the situation, limit when x approaching 4 from the left for the function fx, and we have the value of y approaching 1 over 2, negative 1 over 2. Next, focus on the right hand side. So here we have x minus the 4 minus the 2 over the x. So rewrite the situation, limit when x approaching 4 from the right. So notice that we have x minus the 6 over the x. So if we substitute the 4, and we will have negative 2 over the 4, and we will have limit when x approaching 4 from the right for the function fx, the value of y will be approaching negative 1 over 2. Notice that limit when x approaching 4 from the left for the function fx is equals to limit when x approaching 4 from the right for the function fx. So equal for both sides, and the limit when x approaching 4 for the function fx, the value of y approaching negative 1 over 2. So that is the second step. Third step, we have f4 equals to limit when x approaching 4 for the function fx. The value are the same. Then we can say that fx is continuous at x is equals to 4. Okay, next, kindly refers to b. Given the function fx where we have 2x over the square root of x squared plus 2. By finding the limits at the appropriate value, obtain the horizontal and also the vertical asymptote, if they exist, and then hence sketch the graph for the function fx. So step number 1, find the domain. If it refers to the situation in here, we notice that it is a real number. And then focus on the bottom part, we have the x squared plus with the 2. So notice that x squared is a positive value plus with the 2. Very obvious. If we substitute any numbers, and we will also get a positive value. So based on the situation given, step number 1, the domain is negative infinity until infinity, or we can say a real number. Second step is to find the xy intercept. So focus on the x-intercept means that when y is equals to 0. So kindly substitute the situation, and we notice that x is also equals to 0. Continue. In order to find the y-intercept when x is equals to 0, and y will be equals to 0, so we have the coordinate 0, 0. So for the both x and y intercept. Next, number 3. Focus on the vertical asymptote. By referring to the domain, and we notice that there is no any asymptote, so we can say no vertical asymptote. Step number 4, we are going to focus on the horizontal asymptote. So limit when x approaching negative infinity. For another side, limit when x approaching positive infinity. So kindly substitute the situation. So here we have the 2x over the square root of x squared plus theta 2. So if we substitute, we will have a negative infinity over the infinity where we have the indeterminate form. So my idea is to factor out the x. So if it refers to the highest power of the denominator, we notice that we have the x squared and also the square root of the x squared. So limit when x approaching negative infinity, if we factor out the x, we have the 2 over, if we factor out the x squared, and notice that we have the square root of x squared, which is also equals to x. Square root, we have 1 plus with the 2 over the x squared. So based on the situation negative infinity, we can say that the square root of x squared will be the negative x. So limit when x approaching negative infinity, we have the x, so 2 over, we have the negative x, multiply with the square root, 1 plus 2 over x squared. And we can simplify, and if we substitute the situation, we will have negative 2 over the 1. So limit when x approaching negative infinity, for the situation fx, the value of y will be approaching negative 2. Next, continue. We have the right hand side, 2x over, we have the square root of x squared, multiply with 1 plus 2 over x squared. Since this is a positive infinity, so we can say that limit when x approaching positive infinity, we have the x, divide by, we have the positive x as well. So based on the situation, and we can say we have the value 2. So the horizontal asymptote, we have y is equals to negative 2, and also y is equals to 2. Next, we have to sketch the graph. Okay, so now focus on the graph. Number 1, we have the all real number. So means that there is no vertical asymptote. Number 2, we have the coordinate 0, 0. Number 3, no vertical asymptote. So next, we have y is equals to negative 2. So let's say here we have y is equals to negative 2. Another one we have y is equals to 2. So meaning that when x approaching negative infinity, we were approaching either above the negative 2 or below the negative 2. Same goes to the right hand side, above the 2 or less than the 2. By referring to the calculator, kindly key in this function and then calculate the value when x is equals to negative 50. And we notice that we have the value which is above the negative 2. Same goes to the right hand side. When we key in 50 as an x, then we will have the value less than 2. So the graph will be something like this. So that is the situation for these questions. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.